Welcome back to this course, Introduction to Blockchain Cybersecurity. This is a presentation of coding boot camps. This is our 10th lesson and our final lesson, and here we're going to introduce an alternative architecture to traditional blockchain. It is a DLT architecture, which blockchain is also a DLT architecture. DLT stands for Distributed Ledger Technology, and we're going to talk about the security benefits. So the type of architecture is called DAG, Directed Acyclic Graph DLT, and it's a more recent solution that offers all the benefits of blockchain, but with better performance. Performance has long been an issue with traditional blockchains such as Ethereum, such as Bitcoin. The amount of time that it takes to validate transactions and add new blocks is, by today's standards, quite slow. The current block time, say, of Bitcoin is about 15 minutes. So although the block adds several transactions, it's still relatively slow in performance. Again, the DAG architecture looks to greatly improve on that performance while still delivering the same benefits. With this architecture directed, we have a linking, so we're using linking, so the links all point in the same directions with earlier transactions linked to later transactions and so on. So there you have the example of transactions linking to one another, so you have the immutability of the blockchain. Acyclic, so loops are not possible with the DAG architecture, so a transaction cannot loop back onto itself after linking to another transaction. And the graph, the G, so this is a mesh of connected transactions that can be represented as nodes in a graph network, kind of almost like a virtual node. And here the nodes are joined to each other by links. One aspect of blockchain, traditional blockchain, is that mining takes a lot of time. The miners actually validate transactions, so real-time transactions are slow on blockchains like Bitcoin. DAG, distributed ledger technologies, are built for speed. There is no need for mining because all of the transactions are linked to one another. So it's faster transactions per second, and it's a linking data structure. Again, mining is not needed because each transaction is linked to one another. They're validated at the same time, and that gives that delivers more real-time transactions. Validations of transactions they're signed by the transactors. The time again is much faster, more real-time validation. And the networks are simpler, so it introduces virtualization and real-time linking. DAG networks can also be set up faster, obviously perform faster, and have better security. So in summary, we discussed the DAG distributed ledger technology architecture and how it differs from traditional blockchain, and we have all the benefits, but the DAG architecture is set up to have a faster network, faster processing, and more reliable security as it's less complex and all of the transactions are linked. And the complexity, the lower complexity makes any kind of tampering more detectable. Again, please consult your training materials for any private blockchain tutoring sessions or coaching sessions. And again, also consult your training materials for more classes about blockchain, Bitcoin, overviews of Hyperledger and Ethereum, a comprehensive overview of blockchain use cases and blockchain technology and blockchain development. And again, there are more classes, Corda, more on Ethereum and Solidity, so please do look into it. Thank you for taking this course, an introduction to blockchain cybersecurity. Again, a presentation of coding boot camps.